Okay, hello everybody. This is the last video of absolute functions, and after this I hope that everything is great and I will not need to make another video on absolute functions. So let's talk about it. In the previous video we discussed that our for value over here, our for value over here was our salient point, which meant that we would be moving the absolute function downwards or upwards. We'd be translating it upwards or downwards. And so our y value, or our turning point, would be 0, 4. And that's exactly what we did there. Then I'm going to introduce you to a new section, or not a new section, but an additional observation that we can make from the data that has just been given to us. We know now that when your a value happens to be a really big number, such as 8, your graph just gets narrower and narrower. However, when your graph is like much less than 8, and we're dealing with a half or 2/3, the graph becomes much wider. So that's just an additional observation to make. But now we're going to deal with something new. What happens when you have a number within the absolute value of x? And so here we have y equals the absolute value of x minus 2. If you remember from the previous video, it was a mistake that I was inevitably going to make there, but I corrected it. So now we're introduced to something new. When there is an absolute value when there is a number within the absolute value, like bracket or notation, you always consider that a salient point still. However, it is a salient point on the x-axis. However, because this whole absolute value is encased in these absolute values lines, that means that we change -2 to rather be +2. So that's interesting. So now, just from this, I can identify that my lines must start from here. That's great. Then we have to do what we always do. So we have y equals x minus 2 if x minus 2 is greater than or equal to 0. So that is 2. What I did there is I just brought this -2 to this side. I think it's also important to note, and sorry I moved quite quickly, that when you're dealing with an entire absolute value, it means that your entire absolute value must be represented within our conditions. It just always is the case. And then we deal with what happens if it's negative. And if it's negative, you just treat this like how you treat any binomial being multiplied by negative. Remember, I explained to you that we don't include 0 in the first condition in the second condition, because 0 is indeed a positive number. And so then we'd get y equals -x plus 2. Great. Now we can establish what our positive and negative gradients are. So our positive gradient looks something like this. That's fine. And our negative gradient, let me use a different color. Our negative gradient looks something like this. That's great. However, we can now see, just from making these graphs, that our y value with the negative gradient is going to cut the y-axis. So we're going to have a y-intercept. And it's your job as a student to make sure that you're representing that y-intercept. Great. Okay, let's talk about y equals x minus 2. Remember, I always say, don't be difficult. why are you putting pressure on yourself in an exam? Just make x 1. And so now you have y equals -1. But notice, and this is where my rule always make it 1 can't work anymore. Because if I make my x value 1, then my y value becomes -1. But that can't be right, because my x value must be positive, and my a value is definitely positive. So my graph can't exist over here. And this is why your conditions are so extremely important. Because it says that x must be greater than or equal to 2. So it can only be valid when x is greater than or equal to 2. And therefore when we make x 1, the solution is no longer valid. So let's redo this. I'm doing this so we can actually see what we're dealing with. We then have y equals x minus 2. And we now know that our condition is that x must be greater than or equal to 2. So let's make it 3. Now we have y equals 1. And so then finally, we can plot our point that when x is 3, y is 1. Great stuff. Let's deal with our second equation. And our second equation is y equals -x plus 2. Just a reminder where that came from. It came from there. Okay, and so this condition says that 2 must be greater than x. So we can use a -1. And we'll get y equals 1 plus 2, which means y equals 3. So then we have when x is -1, y equals 3. Or you could simply just put 1 in there, and then you get 1, 3. I think that is much easier, so I'm really sorry if I confused you guys. And then finally, you need to find your y-intercept. And your y-intercept does lie on the graph with the negative gradient, so you just say -x plus 2. And then if you want to find out your y-intercept, you make x 0. But I think we already know that it's going to be 2. This is just from the equation of a straight line, so y equals mx plus c. Your 2 is definitely your c value. And so then finally you can top this all off with saying that your y-intercept is 0, 2. And always don't forget your arrows and don't forget your equations. Okay, great. Now we understand what's going on almost entirely. And the final thing that we're going to deal with in this video, I realize now that I'm definitely going to have to make a video, so another video. So let's just deal with absolute value equations and how to solve them. Because up until this point, we've only dealt with drawing the equations and drawing the graphs, but now we're going to talk about how to solve absolute value equations.